So thank you, Professor He, for inviting me to be part of this exciting conference on edge computing. Of course, I know of this conference for quite some time that's being held in different parts of the world. And I wish it was in person, but anyway, so hopefully next year one. So thanks again for this opportunity for to present a keynote talk at this conference, and indeed it is an honor and privilege. So in this keynote, I'm going to present about Neoteric frontiers, so the recent advances in cloud and edge computing. So in particular, targeting this big data and IoT applications. And usually when we say edge computing, in general, it is associated with supporting IoT applications, the primary, or doing processing of data at the source of data, rather than moving the data all the way to a centralized cloud, can we do at the edge of the network? And of course, the colleagues generally in this research, they're looking into both, how can harness the power of resources at the edge of the networks and the resources at the centralized cloud, and also in between. So how do we do that? So in one sense, you can think of this more as a, sort of a edge cloud at the near data source, and then the centralized cloud at somewhere else. Then how do we harness? Anyway, I will take a look at both this cloud aspect, but more in the context of how we can scale application across all the way from the enterprise or data source level towards multi-cloud, or towards centralized or large-scale cloud environment, which may be far away from the data source. So from that perspective, let's take a quick view of computing paradigms, just in a say half a slide, just to see how computing paradigms evolved, and primarily focusing on cloud and edge. So then we will take a look at the today's application and the new trends, new technological trends and the application trends, and how do they impact on the architecture of cloud or edge systems. So understanding these applications, especially newer ones, that actually helps us to understand what advances we need to do in research, in development, in the software solutions that we create, so that way they are actually useful to real world applications. So from that perspective, I will briefly present market-oriented next generation cloud, how this impact, the trends impact on the architecture. Then obviously we need a solution, a software system that has these features. So from that perspective, I will discuss Anika as one of the cloud application platforms that allows you to harness edge cloud and also public cloud in a seamless manner, for example. So then we will briefly discuss a bit more on IoT. Although IoT has been around in the cloud-centric style, but very specifically about large-scale deployment of IoT, in coming up to next 2030 or so, huge number of billions of IoT deployed, which also means that we need to rethink about how we architect the solutions. And this is where there is more and more focus on edge and fog computing. With a lot of similarities between both, but there are some differences. From that perspective, I will discuss about a few software systems that develop, both a practical software system like Purpose for applications, which I will illustrate through a simple healthcare application. And then, of course, the simulator also will briefly present, like iFoxSim is a simulator that we develop for both edge and for computing, modeling, and simulation. So then we will conclude at the end. So this is a brief outline of our discussion for next 50 minutes. So that way we have sufficient time for interaction and question and answer. So let's begin with very basic concept of computing paradigms, and we are aware of this computing paradigm already, so I don't need to emphasize too much. And all the way from 1960s towards 2030, and we can see different computing paradigms have emerged. Of course, some of these paradigms like mainframe computers were there, and at that time they were thinking about how to make these capabilities available to end users as a utility service, inspired from electricity delivery as a utility and telephone service as a utility. That was inspiration. But having said that, internet came into picture with the goal of making available these mainframe capabilities to end users like utility services. However, that didn't happen. What actually happens is many other advances took place, such as web enabled by internet. Then, of course, web also has been around the last 25 years. So even more interesting is most recent is this notion of service-oriented computing gained very popularity, and that is applied to service-oriented software architectures. And then the concept of virtualization became much more prominent, wherein rather than tying an application to a specific server, why don't we put it on a virtualized machine? Then we can move that across wherever we like. And that has actually triggered for easy realization of this concept of computing as utility computing. And cloud is the one which really made this happen. What was seemed like a dream for many years, and we see that reality through thanks to cloud computing. Then, of course, during last 10 years, good amount of advances is made in cloud computing, and many of us have, did research in that area, published research papers, and of course, there are many practical solutions and products and available in the marketplace. Then meanwhile, this IoT is getting huge popularity. So mainly because it provides an opportunity for us to integrate physical world and the digital world. So we have digital world separate and physical world separate. So can we have a seamless interaction between physical world and digital world? And this way we can create new class of smart environment, a smart application. And of course, that has created another opportunity for, we need a cloud-like capability also at the edge of the network. Simpler. We can compose them and to support these IoT applications. So this is under the name of edge computing in popularity. Then I was in fact looking at some of the description of edge computing, how people are writing, and some of them mean that, we want to bring cloud-like services to the edge of the network, and then we can use them seamlessly and to support these applications with the real-time requirement or low latency requirement. So we'll see more details. So this is just in a glance, just to set the scene. Then, of course, these advances that we see in computing in the past, if you see the history, more and more driven by big scientific application and big military application. But now we see those are actually driven, the latest technology, whether it is a hardware, whether it is a CPU or a memory or a network or any devices, they are more and more driven by catering to the large population. That means no more enterprise is the dominant. So no more big military application dominant. Instead, how do we support consumers, a large number of consumers, and provide them capability, interesting environment, interesting way to operate, and then they become fabric of our life. So that is what is a big push, and that is actually a good thing. So that way we can, every common man can see the benefit of what we do. So that is about advances. Then when we look at cloud, for example, in simple terms, we all know that it offers subscription-oriented services, just like utility. You subscribe to capability and use and pay for what you consume. So here in cloud model, so we have subscribe services where you can rent compute capability, application capability, or platform capability. Then users subscribe to it and use it what they consume. So traditionally, it is not just one cloud. If you are today building a practical application and you want to cater to millions of users, it is actually use of multiple such geo-distributed data centers that are put together and deliver capable users. And some of them are actually near the user. So these days, it is very common to see cloud service provider having presence across multiple regions of the world, and which they are actually promoting that as the edge cloud. That means it is meant for a specific region, an Australian cloud or a China cloud, or and within Australia, within China, multiple places. Similarly, in the United States, similarly other countries. So this is already distributed. And what they're promoting is, now if you have an application with certain privacy requirement, perhaps a better quality of requirement, at that time we will map your request to a nearby cloud that we created in your region or your edge, and we support. So this, I think, edge-like concept is slowly, is got into mind of all the large players as well. So which is a good thing. That is in brief. And just as cloud applications, already numerous applications we all have been using, traditional scientific and business applications, including customer resource management, enterprise resource planning. These are already in cloud, which is a success. Then, of course, coming to the consumer and social application that we use every day. So including the Zoom we are using today is a cloud-based video conferencing software. So rather you can say cloud edge-based video software. That is better definition, because so this software system is harnessing capabilities of multiple locations, geo-distributed data centers, some of them the edge. And even this conference, you can see we have participants from across the world, including China, Australia, and other places, and we are able to get sort of real-time feeling of our interaction. This is made possible through such a geographically distributed model. And my it is possible that my instance of services are running somewhere maybe in Australia or nearby, and others maybe in China, others in some other place. So this will be a highly scalable, large-scale environment that is made possible through Zoom. And the reason I'm emphasizing is that because you are using Zoom today, and I'm just highlighting that architecture and how the concept that we discussed today are actually real life, and of course we see in the future. And other things like Twitter and Dropbox and Facebook, these are actually harnessing geo-distributed architecture, including Dropbox. Dropbox is a cloud storage service. It is harnessing the power of multiple storage devices, including our laptop, where we have Zoom that agent. So that is actually harnessing as well, as you can say, providing seamless approach to large-scale storage that we can share with others, and that we can use it as a backup, where both your lone local resource, your local computer resource, and also remote computer resource are used. So you can say this sort of a harnessing edge and cloud-like capability to give us reliable services. If our red device like laptop, where we have the account, if it fails for any reason, you can get it from a cloud. So and it uses edge more quickly for quick operations, and later on sync with the remote location. You can see already these things are become part of our solutions. That is why we see them more scalable, and they can tolerate failures of network as well. With a brief understanding, let us move forward. It is not just these rapid uses, but they are massively used. This is another important point to remember, that these services that we discuss are actually massively used by millions of users simultaneously. So this, for example, Facebook as a service, geo-distributed, all these edge and cloud capabilities, and they're harnessed to support millions of users at any point. This is a big thing. Then likewise, micro-messaging, likewise, Twitters and many others. So you can see in a minute, so much is happening. So, and of course, every year, this is growing very, very rapidly. So this is just in brief about cloud state of the art. Now let us take a look at the new trends in technology application. How do they impact on our emerging cloud and edge computing environments? So we all know that now this microservices or container-based things are much more prominent, gain popularity. Earlier it was virtual machines and virtualization. Then of course virtual machine creation takes a few minutes, sometimes 2 minutes. So the same, instead of that, we can go for microservice architecture, which can bring up quickly, so in few microseconds. And these microservices are getting even more popular in the edge network. So, so I will talk about that as we go along, but I want to highlight these trends. And the next, of course, IoT, as I mentioned, gaining popularity. Then because of this IoT and we have too much of data collected, then that becomes big data. Then, of course, to support them, we have all this edge and for the new next incarnation or next extension of cloud. Then meanwhile, this software-defined networks. Now, these are our network environment. So one is using standard, traditional network. Other is we move towards software-defined networks, which allows us to virtualize the network also. So compute virtualization through VMs and then network virtualization through this SDN. And of course, this is seems like very easy to say, but in terms of deploying a right amount of bandwidth and capability to different applications that are competing, so that is very unique. And this is where the concept of network slicing, and how do we do that? What is the approach to slicing and how do we slice, how much slices we allocate to different users? This all depends on the quality of service that we need to deliver to end users. This blockchain is another popular thing everywhere. Blockchain itself is a separate conference, but I want to highlight that we can use this blockchain in our area, in edge environment, to create trustable services. So I will discuss about one of our efforts in that area. How do we create trustable services using blockchain for supporting healthcare application, IoT healthcare applications, where we can trust the result. So because when we have a network environment, somebody might tamper the data or tamper the result. So I want to make sure that the data result that I'm getting are actually trustable. Nobody has tampered on the path. So blockchain can be used. So then, of course, these days we hear a lot about AI, and AI on the edge, AI on the cloud, and what we call, distributed, all this AI technique like ML and deep learning using on this environment. And we hear a lot about edge AI also. Then, of course, these AI or IoT, all this together provide such an excellent opportunity for us to create smart environment, and some people call smart applications, and applications in different domains of our life activity. Then, of course, this COVID-19, needless to say, impacted so much in the world, and the use of this cloud-like systems has actually escalated during last 18, 20 months. It almost like it doubled. So this, of course, COVID-19 has impacted and threatened all the education become remote education, conferences become remote virtual conferences, and we are experiencing already that. But the good news is that our cloud things have actually supported during this period a lot. Networking and cloud played an important role. I think we all need to be very proud about what we did during the last few years, thanks to cloud computing and advances. Then these AIs are another very prominent workload these days. So if you're doing something, you do for AI. For example, if you're doing edge computing, can you do your advances in the context to support AI, which is called edge AI? Or if you're doing some other, business analytics or a services you're creating, incorporate AI. So this is, became everywhere very dominant, and we see the use of, AI techniques, and of course there are many applications. So henceforth, when we are building our edge solutions, we need to think about, are there any unique requirements? So these applications, put on us. And certainly they do, depending upon whether you pick up a driverless car application to create a smart environment, or better transport system, or healthcare application, or robotics. So the way we create necessary solutions for those using whether a network or AI or cloud. So there are some unique characteristics. So of course, even some of the companies in the business of CPU, they are creating application, the CPU, central processing units, very unique to AI workload. So like TPUs, for example. So these have come up very unique. Then even in hardware level, and many of we also hear about quantum computing. So quantum perhaps may be useful for security applications. Not everywhere these days. Primarily very prominent. Now this quantum is also accessible via cloud. So just like, not only standard CPUs, but also accelerators and GPUs and quantum. So what does it mean for people doing research? So this presents a new opportunity. How do we engineer platform, software system that can scale across heterogeneous, computing element within a server, like that multiple of those. Okay, so so having understood these trends, now let us start briefly look at the architecture, then look at the software system, especially latest version of the software Anika that we built to meet these needs. So very briefly, this next generation market cloud, it is a collection of servers in one place, for the other cloud data center that are interconnected, and these are virtualized computers like through VMs and networks like through SDN. Then of course on top of it, you have microservices. Now let's go up at the user level. So a user have certain requirements, and the requirements are in the form of quality of requirements such as timeliness, deadline, or a budget, or price that we need to pay. Then the request comes to the system, and system has admission control to see whether the request can be honored, considering current capabilities and the commitment. So when the request comes in, so let's say based on certain policy, you admit, and for that you create a virtual machine, and the virtual machine mapped to a physical machine. Okay, so application on this is running, then services are being delivered to end users. With time, number of users can increase. When number of users increase, what do you do? In this case, we may have to provision extra resource within one cloud or across multiple. And what is it across multiple cloud? If the users, for example, the Zoom software running in one of the place, and slowly the number of users coming from different countries and increasing at that time, so it creates an instance and then maps that request, those requests to edge data center. So edge data center, that way we can provide a quick, better service to those users. Then, of course, when these users in some of the places are decreasing, so given that world is is like a follow the sun, more and more people operating when the daytime is there. At that time, other people who are at the night time, maybe you can turn off the capabilities on those locations, so this way you can use them efficiently. Efficient uses of resource. Then, of course, this is called what we call elasticity property. Elastic property not only within one cloud, but also across multiple clouds, whether they are edge location or at some of the core location. So this is elasticity feature. And elasticity feature, to realize that feature, it requires us to engineer systems. Also, it requires us to engineer applications in a unique way. So that we can harness that capability, scaling or continuing of computing across one location, other location. Then, of course, when the demand decreases, you can shrink it, maybe one location itself. So this is how the system is supposed to operate. This is a conceptual model of scalable, distributed, what we call multi-cloud computing with edge integrated. So that's all conceptual. Now let us briefly look at a software system, the recent advances in this area on enabling this model. So one is when we think of such a system, first we need to have applications that can harness this capability, and we need to have applications that exhibit this capability. So which also means that we need to have a software development environments and a programming kits that will help us to create such applications very easily. So when we look at concurrent application programming, we know that there is something called thread model programming, there is something called task, SPMD, single program, multiple data programming, then there is something called MapReduce, and like this, different models are emerging for different applications. So here is our Anika software, is a software development kit that contains APIs for multiple of these models that helps building different applications. And once you build it, you can deploy on a enterprise or a edge cloud or on a public cloud or run across. If you're running your application on a edge enterprise cloud, whenever you need extra capability, you can use a remote public cloud necessary whenever required. And that is made possible through this runtime machinery, exhibiting this continuum computation across edge and the remote cloud environment. And how is this made possible? This is made possible by Anika's container architecture. So Anika has the foundation container services, and these container services can be extended to meet the needs of specific model of programming like a thread or a task MapReduce. So for example, for tomorrow's edge system, you come out with a very unique lightweight model of programming. So you don't want to use all this MapReduce or all this very heavyweight. So you want to go for a lightweight. So within Anika, you can actually create your own. Then when you deploy Anika container within the edge resource, because that resource may not have a powerful resource. So there you can deploy just Anika's container, and then the container with only that unique model of execution needed for that application category only, not for everything else. So this way you can have a lightweight deployment. So this is the unique architecture we have, which is like a hot pluggable. You can, during setup, you can say, I want these services, I don't want these services. So depending upon needs. If you created some edge device, especially for just one class of application, it only run that workload, no need of having all the things, just what we need, that's all you deploy. So that way we can have a lightweight approach. So this is a software system, world first, having such capability, then also able to deploy in a seamless manner across. So this, this is Anika in brief. So this Anika actually been around. So as the concept evolved, we have extended this Anika technology. So originally, targeting bioinformatics application, then later on, events processing, then this data mining and mobile clouds. Of course, the most recent is innovation is more about supporting this AI-based, application models. When we say AI, that means like a deep learning application or machine learning application. So we'll briefly take a look at how we supported them. So this is just in brief, the latest version Anika 5G, which is very much geared toward this edge and multi-cloud harnessing, capability. So when I say multi-cloud or a edge cloud or a remote cloud, so obviously if you are operating, we are going to come across varieties of clouds, so and varieties of edge setups. So you might have a private edge cloud in your organization near your data source. Then, of course, these other public clouds are there. They may be, Amazon, or maybe Azure, or that may be, VMware-based cloud, or it may be based, or it may be Baidu, whichever, the multiple clouds are there. And we want to build application that can scale across as necessary in a seamless manner without modifying the application code. And we know that as researchers, as developers, we know that each of these clouds have their own way of, their own interface that allows you to run tasks remotely. So therefore, the application developer don't want to know about all of this. We want to hide them. So to hide that, Anika has various software adapters for each of these cloud environments. So whether it is Azure or OpenStack or Amazon, so that way the applications created using this Anika APIs can run across in a seamless manner. The developer of application no need to learn about other low-level things. So this is just in brief how Anika supports such continuum computing, or aids to cloud computing. Let me briefly share the use of this in 2 or 3 applications. Then we will switch to more pure aids. Okay, so this is a mixed thing. Here are a few examples. Say, for example, one from China, other from India, and third one from Washington University. And like this, different users community have created very interesting application. So, for example, this Washington State University. So, Washington State University usually to carry out this privacy-aware medical data analytics. When you have medical data, certainly there are sensitive records and there are non-sensitive records. So if there are data records are sensitive, at that time you use a edge data center located within your hospital. And when, if not, so some non-sensitive records you can process on a public cloud. And this is what they did. They plugged the concept of classified medical records to Anika and classify records, then those which are sensitive marked as for private cloud or edge cloud only, others to the public cloud. So they have done such interesting work by plugging their ideas to Anika. Anika is an extensible system. So if you've got a new idea for a new model of programming or a new requirement, you can actually extend. So we have APIs that are exposed for software developers if they want to use it to create their own system innovation. So now let us take a look at a few of these, examples, then illustrate this concept. So this is from, China Rolling Corporation, and here various, locomotive trains design scenarios. You want to find out which are scenarios are the best and optimal for this requirement. So the first model of their computation was just using a single server. They were doing this analysis, and this was taking a lot of time. Some of this computation used to take anywhere between 24 hours to 80 hours, like 1 day to 4 days. And for that purpose, they set up this what we call cloud at the edge capability by harnessing some of this capability within the enterprise. And we have a tool called Design Explorer. Using Design Explorer, they are able to express this application Maya as a SPMD, single program multiple data application model, and then using which they're able to analyze for different number of the design scenarios and images. And when they processed on the single server, what took for like 80 hours, 24 hours to 80 hours, the same thing they are able to do in 2 hours. Now you might say 2 hours is also too much. My requirement, I want answer time, what we call this, time, I want answer in 10 minutes. What do? My edge cloud within my enterprise takes me 2 hours, but now there is a critical requirement. So maybe some important person, president of a country visiting your organization, and you want to show that person the quick results. So maybe 10 minutes. So then you should be able to set deadline equal to 10 minutes. Now my local resource takes 2 hours. I want answer in 10 minutes. So what do? I can use the resource from the remote clouds. And these services are provided by either Microsoft, Amazon, or Azure, or Baidu, or whoever, they're different providers in different countries. So you said deadline is equal to 10 minutes. Now budget is equal to, say, $3. Given a deadline of 10 minutes, budget equal to $3. Now Anika on your behalf looks into marketplace of the distributed cloud resources. What is their prices and how much I need for this application given this deadline, according to rent extra resources and move the computations and bring that result. So just like in our real world, the way we operate, this market aware, economic aware, the QoS aware, resource provisioning, QoS aware execution of application, that is through scheduling research. So these are resource provisioning and application scheduling. So these are market aware. So this is the kind of thing we build, and that is why I mentioned about this adapters concept. And right now it works. So there are many examples, research paper we publish in this area on algorithms. So how it works. Okay, so there is one from China. Now let us take a look at healthcare. These days, healthcare is much more, prominent, exciting application everyone want to hear. So here is an example of the sensor, like a body area networks. So earlier we used to call sensor. Now with the IoT paradigm, it became very like a common thing. So these sensors data collected, and obviously you can send the data to your mobile phone. From there you send it to remote cloud. So where remote cloud is, here is a software as a service, ECG data analytics service running on Anika on Amazon Cloud. So when a request comes in, the system, these requests goes to this here. The Anika is able to provision right send up capability. Now look at the users. And users' healthcare application can be numerous, can change from time to time. And each of the users have a different requirement. Some of them are in emergency. They want answer within 1 minute. Correct? In healthcare, you may want 1 minute or only a few seconds. Very important. Whereas those who are relaxed, like just caring our health regularly, just see how I'm doing. So you don't have to just do, very reactive all the time, but just proactive once in a while. So such a requirement, different users with different deadline, different amount of price they're willing to pay, and the request comes in. Anika has ability to allocate all these requests and manage in such a way that their requirement of this, different users' requirement of deadline budgets are met. So this is a multi-user scenario. So this is something we have actually demonstrated much more recently, even at CCB conference. Then of course now it's evolving rapidly. So here is the data, the data that is captured, the mobile phone, and then it's sent to cloud somewhere remotely, and the results came back. And of course, just by looking at this graph, you can see a lot about person health, how he's doing, whether this person is having good sleep, or maybe give recommendation. You better, if you want to take care of your health long term, you better take sleep. These days, good sleep is important. Now these days, due to all these multi-conferences, conferences, we start participating in remote conferences, which are held in their day, but we hear in the night. So it can be challenging. But anyway, so such applications was created, and very interesting integration of sensing, mobility, and cloud, along with analytics. So that is healthcare. Now let us focus on two AI applications, very unique AI. So AI, usually, AI, when we say inside, there are a few more, this deep learning and machine learning are part of broadly AI. So here is an example of creation of deep learning application for object detection using Anika's programming model. So like these sensors, or cameras and videos, they're capturing constantly the data, and the data comes to sort of gateway machine. And then here is the, for example, a small scale edge cloud within enterprise, and these are remote clouds. So using Anika's APIs, this program called deep.py is a Python library for deep learning, and our colleagues, some of the researchers actually in India, so they created at IIT Delhi, created this application where these deep learning tasks are, when the request comes in, we want answers in real time. So therefore, many independent tasks are created, and these tasks are distributed either within Edge Cloud or the remote cloud in a seamless manner. So that is, and of course, here you can see, for example, in computer labs, so these images that are coming in, or videos coming in, you can classify into these objects like a monitor or a keyboard or a mouse, and of course people also, like there may be how many people are using this lab effectively, or is it everybody empty? If everybody empty, then maybe all the computers can be turned off. Such a planning can be made. So and of course depend upon the latency accuracy expectation. So how accurate you want object to be detected. So based on that, the time it takes to compute can also change. So this is the an enablement of deep learning application across edge and cloud data centers. Now, so this is my last example of that involves a bit more cloud concept. So this is mining, this COVID research data. So during last, 18 months, almost 2 years, let's say 18 months, so more than 250,000 papers are published. I think our research have become very productive. And everyone is orienting their thoughts and thinking toward this area. So whether if you're a computer scientist or a cloud scientist or a health biomedical person, you see, oh, how can I orient my research into cloud? If you're an economist, how can I orient? If I'm a medical guy, oh, I want to orient towards developing better vaccine for different variants that are coming, not only the main coronavirus, but also variants. So there are so many papers are published, and you want to find out what is the effective progress in this area. Maybe we are getting a new variant, and that variant is there any solution, is there any quick publication. So going through all those papers, like 200,000 to 50,000 paper is, a big task. Or you maybe create a machine learning program that classifies this into, here are the latest, very oriented towards your search. So a specific, variant or a delta or a micron, whatever variant. So that kind of search, what we did was we created a machine learning, application, and this machine learning program is like NLP. Natural language processing on a cloud. So you're basically targeting this COVID data. We took this code CORD19 data set, the data set, and created this machine learning application. And of course, this the data sets, when you have large amount of data, you can divide, and then snapshots of the data are processed using different tasks on different Anika buckets, and the results are presented graphically to users. Here is the actually execution time. So when you use a single server at the edge, for example, this took something like 25 minutes. The same thing by using many more resources, we brought it down to 4 times reduced election if you use a 4 server dynamic printing. And of course, if you need even more real time, maybe within 1 minute, then you provision extra resource. That's what I'm highlighting, that Anika allows you to do things for machine learning and in the context of this COVID research data analytics. So this is just more of a latest, and we published a paper on this as well recently on this area. Okay, that's about this Anika. And if you want to explore Anika yourself, Anika 5th version, and we released recently, and you can download from this our mandrosoft.com. So this is our spin-up company that offers a commercial grade solution for the marketplace. So that is about, in brief, how, Anika technology has been rapidly extended to cater to the needs of latest applications and harnessing latest technology, latest concept, then bringing notion of edge cloud and public cloud together. And of course, many universities around the world are teaching courses in the area, in China, in India, in South America, in American university, they are teaching cloud computing courses. And for example, in India, many places they're teaching these cloud computing courses, and they're using Anika for providing hands-on experience to students on application programming. Similarly, in China also, a couple of universities in Chengdu, in Beijing, in Changsha, few places they're using to teach these places. Like even the place where Chairman Mao is born, and that place also. That place, what is the name? I forgot. Anyway, that city. So they use this Anika for teaching in China. So like this, in Spain, for example, they are teaching application programming to students in one of the Spanish university using Anika for that purpose. So that is about a bit more cloud edge type of concept, but it is more of a cloudist. So now let us move towards pure edge. Okay, I think that is also very interesting. Although we want to integrate, but pure edge is important. So this is where IoTs are the very dominant, driver for edge applications. So why should we bother? So it is projected that by 2030, the number of IoTs deployed will be 10 times more. So minimum 500 billion objects. Each person possibly have so many, like a watch with healthcare analytics, and then maybe some set that body networks, and then moving around. So then like this, vehicles and everything. So huge number of objects to become part of internet. So that means we are extending concept of the internet, which is networks of computers to networks of everything. And as a result, it is projected that this presents not only technological opportunity, but also huge economic business opportunity. Something like more than $10 trillion per year opportunity, which is driven by IoT. And of course, what are these IoT? So not just computer, you can see, the trees become part of internet, the lights become part of internet, your fridge become part of internet, our watch become part of internet, we become part of internet, our body become part of this internet. So, this is an exciting opportunity. And then as a result, we see adoptions everywhere for various purposes, whether it's a manufacturing or a home automation, various places, adopt it. So increased deployment of IoT. So here is just a more of a cartoonist way of explaining, showing that worldwide IoTs are gaining prominence, which is a good thing. And such a deployment allows us to create smart world. And when we say smart world, of course, individual element need to be smarter to make a smart world. So, for example, homes, smart home automation, then healthcare, obviously, especially during this pandemic, this is even more important for remote health monitoring. So, how can we do that? Then this smart transport systems, better route planning, and connected cars. When we have connected cars with automation, with IoT deployment, so we should be able to avoid the, for example, accidents when you are crossing at signaling point. So this is quite a lot of interesting work. And then of course agriculture, then grids, smart grid. So these days people talk a lot about micro grids and then the standard grid. So when we have micro grid, a community. Small community have a grid environment. They are power consumer, also power producer also. Like on our home, we have this all solar panels. We are producing, but during daytime maybe consumption less, but we are producing more. We can feed into grid. So this is where the interaction, two-way interaction between the consumers and the producer, and then put into grid, and so that the community can say across multiple micro grids or across the grid itself. So this is these are the applications. Now, what do we do? So there's too many applications, too much deployment. We don't want to push this data to cloud environment. We want to create different. That is the pure edge, for example. So here are in summary. So IoT applications so far the first generation cloud centric. Okay, but if you go for 2030 with billions of more than 500 billions of objects, if you go for IoT cloud centric, centralized cloud centric, push all the data to cloud, what happens? First, internet get cloud. Correct? You know that internet primarily big traffic is the download traffic. IoT is only upload traffic. So because upload traffic is very less and download traffic is very high, traditionally the way applications are created, the way resources are allocated, they give higher bandwidth for the download link and less bandwidth for the upload. But with this IoT, all upload. So too much. It will clog the internet, plus our response time maybe not suitable to support real-time applications like vehicular cloud, vehicular, smart vehicular applications. So what do we do? So in this case, why don't we use resources at the edge of the network? And they don't have to be cloud like a micro cloud, no. So they can be just few micro, like a Raspberry Pi devices at the edge. So can we harness, like in a smart hospital, so near a bed of every patient, there'll be a small Raspberry Pi, a small compute device. No need of cloud. So there may be cloud like small data center, maybe in the hospital, but near the user is just a small device, compute device. So that is the devices. Then of course, this is something maybe at the hospital, and this is the remote cloud. So we should be able to use either cloud or just a pure edge, or maybe pure edge hospital cloud, or pure edge hospital cloud and also remote cloud. You see. So this is why we say here, you can say this is more of a edge computing. And if you are trying to harness this multiple of these along all the way from edge to remote cloud, which is what is called fog computing. And of course, the people are using these terms interchangeably. Some say edge computing, some say fog computing, some say continuum computing. These are different terms. Let us say use edge computing. This is a conference focus on edge computing. Let's focus on edge work. So to be able to use edge resource or a nearby resource and the remote cloud in a seamless manner. So this is another interesting area. So conceptually, we all know that what are the elements are involved. And in that direction, we have developed a software called FogBus. It's a new framework, lightweight framework for edge and fog computing with blockchain embedded. So why blockchain? So first, as I said, we need to provide trustable services. If someone take this IoT data, say healthcare data, and then they use maybe some of the edge resources, and all these edge resources may not be owned by them. If I am having some kind of device and I'm moving from one location to location, so maybe I did computation somewhere at another location, then can I trust it? Can somebody tamper the data? So anyway, so these data coming in, then using the blockchain, I can create block of the data, then chain them, then send it to processing, and it just come back. If somebody has tampered, the block is broken. then I can say I can't trust this anymore. So within Anika software framework, sorry, this Fogbus framework, so we have a, in this framework, you can turn on. Turn on means you can say blockchain flag equal to on or off. If you say on, that is true, then of course the system will create the blockchain. If it is off, then it will not create. Obviously, if you say blockchain enabled, then it will take more time to give you result. Or you need to provide an extra resource to give result in the same time. So that is a blockchain notion of integration in Fogbus. So this framework has various entities. One is this device, IoT medical device. Then of course, there's like a mobile or a gateway nearby. Then these are compute nodes. These are the small scale Raspberry Pi nodes. Then of course, here is the Fogbus resource manager. Then this is some public cloud somewhere. This Fogbus is integrated with Anika. If you're using remote public cloud, just use Anika APIs that will manage the execution because it's already designed for that purpose. So this Fogbus software, we have demonstrated many applications. So let me just briefly show one example demonstrator. So for example, healthcare. And of course, there is something called Internet of Medical IoT devices. So I think healthcare community is giving a lot of priority, especially for remote health monitoring. And remote health monitoring, many things, including like monitoring ECG level, glucose level, and blood pressure, and especially during COVID-19 respiratory, how people are doing. Then of course, health management too. So these different places, these IoTs can be used. And today we will just take a look at just one application. So that brings to, for example, sleep apnea analysis. The people having this sleep apnea problem. So here, using this non-invasive device, oximeter, it can be part of the finger, the data captured. So, here is the nearby or a mobile or a healthkeeper app that we have. So this healthkeeper app is collecting and the data comes here, and this can send it to nearby edge where the processing is done. Then after processing, of course, is able to classify and explain whether the severity of the disease is a mild or a normal or emergency. You can at least give the signal. If it is mild or normal, don't worry. If it is emergency, perhaps you need to call 000 ambulance. Correct. So here we integrate all this technology, and of course you can also even control the level of frequency of data recording and so on within this healthkeeper app. We inspired this. Actually, this initially we created pre-COVID era. I can't believe that we gave this name Healthkeeper. So these days in Australia, they talk about JobKeeper program. So we have Healthkeeper program here. And this was demonstrated here. You can see we connected this oximeter and data and openly demonstrated. And this data mobile phone. And from there, we were able to process either on this Raspberry Pi. So these are open. You see Raspberry Pi, this is like a small matchbox size computer available for maybe $10, $15. So these Raspberry Pis we integrated along with the remote cloud as necessary. We are able to use the resources like this, Edge Raspberry Pi and the remote as necessary. So and produce results. So there are various experiments that we conducted with blockchain R, just Edge only or cloud only or Edge cloud. All these experiment results are given. You can read more about this in our Fogbus paper. And this Fogbus software, we didn't leave there. Just recently, we extended it for microservices. And it's very common these days to use microservices in creation of edge applications. So therefore, we thought we should support microservices. So this is called Fogbus 2, second generation Fogbus with all these microservices, especially to support many this application. And we even created something like, these days people saying that if you're entering into a building, you must be masked, correct? So detecting mask, if somebody has a mask, don't open the door. So like that concept, the detecting real-time mask, because if mask detection takes a few seconds, it's not interesting. It's real time. So at the gate, so you have a small device and this data coming in, the camera is capturing, quickly it will see, oh, this person is masked, hello, otherwise block the person. So for example, that kind of demo we showed with this microservices and Edge one. You just look at our Fogbus 2 paper, you will see more details about it. So this is that's all practical. So we also do modeling and simulation work as well. not everything practical. We know that practical work actually requires enormous amount of effort in building, and also if you have some policy evaluation, practical environment modeling and simulation, repeatable experiment is a bit harder. So for such repeatable and controllable experiment, researchers use modeling and simulation approach to help them. In cloud computing, we had CloudSim. For this edge computing and for computing, we have this iFoxSim. The simulator that allows you to create as many IoT devices, properties you like. Then you create environment. Then you can evaluate your ideas for what is the right approach to resource allocation for this microservices, for example. So this is the iFoxim that we created. So this is already thousands of users worldwide use this iFoxim. So then, of course, similarly, just recently, just maybe a month or two, so we released the new version of iFoxim, essentially same as iFoxim 1, plus we added these microservices explicitly. The people who also want to do modeling and simulation of microservices. So we have that. Then, of course, mobility. So these days, people want to move from the static set of IoT to the dynamic, movable IoTs. So in autonomous cars, for example. So to support them, we also provided the notion of mobility of IoT entities within the simulation and modeling and simulation. Plus, people want to use some kind of clustering technique in better decision making. So we also have a few clustering libraries as well. So that is what we call iFoxim 2 that has these new features along with this earlier core iFoxim. So this is also open source software. This is created in Java. You can download and explore for your application. Final, before I conclude, so this is drone. These days you have to do something with drone as well, and of course in the context of COVID. So here is the a drone fitted with thermal camera. During lockdown, some of the cities, people are living in a multi-story building. Then, of course, they have balcony. So, in India, for example, this is something we experimented. So, a camera with thermal camera, fitted to the drone, is able to go around the building. Then people were standing in the balcony, and it is able to detect if anybody has a fever, which is something like a COVID-like a symptom. So this data that is created and then send it to nearby edge resources where processing is done. Then, this person among these 100 people, this person seems to be having a symptom like a COVID. So perhaps if it is so, then perhaps isolate the person. So this is the network system that we created. Then, of course, there are lots of open challenges here. But this was a initial prototype work that was built, and then we wrote a paper on this. So if you search for drone-based network system for COVID-19 pandemic combating, you will find our paper, which is published in FGCS, Future Generation Cloud Computing Journal. So with this, let me conclude. So to conclude, there are several computing paradigms that have promised this vision of how to make computing a utility that was cloud made possible. So not only a cloud, but also across multiple clouds and multiple edge cloud. And this exciting application is already there. And we looked at, and Anika is one of the technology, especially designed the latest version, ability to support harnessing the power of edge clouds and the remote cloud as necessary based on user requirement, and also providing various APIs to construct applications that can scale like this in an elastic manner. And we briefly looked at engineering application, healthcare, then of course, few AI examples like object detection or COVID research data analytics. Then of course, our colleagues have done smart healthcare, smart cities, and so on. Then this IoT in particular, the first generation IoTs were cloud-centric model, and the next generation, what we see is now more and more edge and edge and edge. So wherein you can integrate edge, local resource, the remote resource, and this way we can support low latency applications, I would recommend. Plus you can reduce the load on the internet. So of course, there are many future challenges for both in edge and cloud computing. So in this manifesto we put together 2 years ago, so it actually has contributors from all over the world, from even from China hygiene, then of course various colleagues from Empirical London, then from IBM, and HP. So various colleagues have put together and then identified the trends and challenges and provided a lot of future direction, where there's a lot of discussion about edge and fog computing there as well. So those who are interested, please take a look at. This is published in ACM Computing Service. So if you are new to cloud, so here is a book to read, Mastering Cloud Computing. This is American edition, $100. Don't worry. For India, for example, we have $10 book. So in Indian print. Then for China, don't worry, just $3 book in Chinese language. So Mandarin language, this is published by China Machine Press, localized content. So this is also, that means when we bring these services and target to different regions, we need to make prices, service pricing in such a way that is affordable to local consumer. This is something we need to think in our service engineering as well. Then, of course, here are some edited books on IoT and edge computing. And this area is rapidly progressing. And of course, these days people use ML for everything. So I just published this book, it's on my desk because I got it just this week. ML-based approach for cloud resource management. Then, of course, mobility is another big fashion. So just 2 days ago, I got this book, Mobile Edge Computing, correct? So you have to provide mobility also, not anymore static. So with this, let me stop here. And here are my email IDs if you want to connect. So thank you very much for hearing patiently. So I can take a couple of questions. Thanks.
Thank you very much, Professor Buyya. It was a inspiring keynote speech, and in all these books, they're really good. Covering basically everything that we need to know from 10 years ago until now, and maybe into the next 5 years. All right, ladies and gentlemen. So, do we have any questions?
There is one question in the chat box. Can I answer? Oh, sorry. Oh, no, that was a query from you.
Yeah, actually, I have a question. So everyone has been saying that edge computing is part of 5G, but 5G rollout is not as fast as we thought it would be. And now some countries are starting to think about 6G. So what do you think about the future of edge computing? Is it still going to be an important part of 6G or in our future?
Yeah, so this new paradigm called human-machine interaction. Human-machine interaction or machine-machine interaction or vehicular, this what we call autonomous cars, for example. So there, the rapid interaction requires, perhaps capability like a 5G or 6G, correct? And then edge building on this 5G, 6G can be good thing for applications of that nature. So yes, there is one. Other one is, of course, edge by itself can stand and support the healthcare application. So there, maybe 5G is not always a requirement. But if there is a critical monitoring, continuous monitoring, that time you need it. Because, in the healthcare devices, this data, monitoring period, so frequency. The frequency can be like a 10 times per second or 100 times per second. So if you want the final level of monitoring, then you need this such high-speed network. Otherwise, we should be able to operate within whatever network available. Yes, 5G and 6G, they present enormous opportunity for carrying out this concept of network slicing better. That means, depending on your application, you can allocate right setup capability. If it is a medical, very emergency, provide better quality. If it is normal, once in a day monitoring, no problem. The simple little allocation of the capability. So yes, this 5G and 6G enabled edge computing is very important. And of course, as you said, before 5G, now people talk about 6G. I have interaction with colleagues on this human-machine interaction. They talk about 6G. We want to create 6G, to support all these human-machine interaction applications. Yes, then which also means that our approaches to application creation need to change. We need to be able to extend to in the context of the newer platform, newer infrastructure.
Okay, thanks a lot.